In this video, I'll give you basic and fundamental knowledge about atoms and subatomic particles. Okay, so we'll be covering what is atomic name, what is atomic mass, and what is atomic number. See, an atom would be represented in this format. For example, hydrogen atom. You can see a number here. See, bottom left corner you can see a number, top left corner you can see a different number. So this is the representation, where X is nothing but name of the element, here in this case hydrogen. Now Z is nothing but atomic number, and what is atomic number? Number of protons inside nucleus. That is atomic number. Now always an atom would be identified as number of protons inside a nucleus. Now when the number of proton inside a nucleus is changed, for example now it has 1 proton inside, now when it is changed to 2, then it is not hydrogen atom, it is no more hydrogen atom, that will become helium. Whatever may be number of neutron, whatever may be number of electron, an atom, an element would always be recognized by number of protons inside nucleus. The moment number of protons change, then the atom, the whole element is changed. Okay, so this number is very important. The moment you are mentioning it as 2, then you have to change the element here. Just go and search in periodic number which element has got 2 protons in the nucleus and change the name accordingly. Okay, so anyway it is 1 atom here, 1 proton here, so it is hydrogen. Now next thing is mass number. What is mass number? Number of protons and number of neutrons inside the nucleus. So total number of nucleons. What is nucleons? Elements inside nucleus. So total number of nucleons is nothing but number of protons and number of neutrons, because only proton and neutron is present inside nucleus, right? So this is the total number of nucleons, or number of protons plus number of neutrons, and this is only number of protons. Here there is no representation for number of electron, because number of electron can change anytime. See Na, the moment it become Na plus, it lost 1 electron, no change, it would be sodium itself. Okay, and Cl, the moment it gain electron, that will become Cl minus. So number of protons and number of electrons in an atom is always dependent on which element it is making bonding with. Okay, so here with Cl it is making a bonding. So how it has made a bonding? By losing an electron, by giving an electron to chlorine. Chlorine becomes Cl minus, Na become Na plus, and then an ionic bond is formed. So there is no representation for number of electron here, because that can be changed at any moment of time. Okay, so here X is number of element, name of the element, A is atomic mass number, and Z is atomic number of protons. Okay, so take this example, H11, H12, H13. Can you tell me number of proton, neutron, and mass number, atomic number, all the concepts. So first we will take A, Z. In Z I have to get 2 values, number of neutrons and number of protons. So here what is A? A is mass number, it is 1. Okay, sorry, A will have this thing, and Z is number of protons. So here Z is equal to 1, number of protons present, here it is 1. Now anyway it is having 1 number of protons, so I can mark it here. So number of protons plus number of neutron is 1 here. So 1 plus 0 will become 1. So that is mass number. Okay, so mass number is equal to 1, and it has 0 neutron and 1 proton, and Z is atomic number, which is 1. In this case, what is mass number? 2. Now in mass number, number of neutrons and number of protons I need to know, and atomic number. So atomic number is simply number of protons. So 1 that is equal to number of proton 1. So 1 plus a value is equal to 2 and n has to be 1. So 1 neutron and 1 proton. In this case, mass number is 3 and atomic number is 1 because 3, A and Z can be immediately given out, 3 and 1. Now number of neutrons and number of protons. The moment you get the value of Z, you can copy it down here and 1 plus a value become 3, so this become 2. See, hydrogen is in different form. The reason is different number of neutrons present in nucleus. Okay, the moment value of neutron is different, these are 3 different, I can say these are isotopes of hydrogen, but still it is element hydrogen itself. It will have the properties of hydrogen, but these are isotopes. I will explain you what is isotopes and isobar and isoton in the coming lecture. Okay. So we got the total number of proton, total number of neutron and the total mass number. Now what is mass number and atomic mass are related? Okay, atomic mass number is simply total number of nucleons present, right? But is that the actual mass? No. See, now when I am saying mass number of hydrogen is equal to 1, which means the number of nucleons is equal to 1, that is nothing but presence of 1 proton. But see, actual mass of the proton is 1.000727 U, and you know how atomic unit can be converted into kilogram. Just watch the previous video. I have explained you how to convert atomic mass unit into kilogram. So anyway, here mass number of hydrogen is 1, mass number of deuterium is 2, mass number of tritium is 3. But see, when it is 1, the actual mass is not 1 unit. The actual mass is 1.000727. This much atomic unit multiplied by the value 9 point something into 10 power minus 27 will be the actual kilogram. Okay, so that is the atomic mass. This one is atomic mass number, mass number, and mass number. Okay. For mass, you have to get the values in atomic unit or in kilogram. Okay, this mass number can be just represented as an integer. So mass number would always be an integer because that is the total number. So always we will be counting things in integers, right? 1 apple, 2 apple, 3 apple. Similarly, 1 proton, 2 proton, 3 proton, 4 neutron. So these would be number. So always this would be numbers. But mass need not to be an integer. Okay, mass, see, is that an integer? Is this an integer? Is this an integer? No, right? Okay. Now, how can we find the total mass of a nucleus? Here it has 0 neutron. In hydrogen it has 0 neutrons, 1 proton and 1, 0 neutron. Inside nucleus these are elements. Okay, 0 neutron, 1 proton. Here 1 neutron, 1 proton. Here 2 neutron and 1 proton. How to get the atomic mass from it? So now here in this case 0 number of neutron, leave about neutron, and number of proton is 1. See the mass of proton. So this would be 1.00727 atomic unit. That would be the mass of one hydrogen nucleus. Here in this case, what would be the mass of deuterium nucleus? In deuterium nucleus we have 1 neutron and 1 proton. So just check, get the value of mass of proton from here. So it is 1 into this much, plus we have 1 neutron as well. Okay, so that would be 1 into mass of neutron is this. Now in the case of tritium we have 1 proton and 2 neutron. See, 1 proton and 2 neutron. So mass of proton into number of proton. Here in this case it is 1 plus mass of neutron, 1 neutron into number of neutron. Here in this case 2. So we have considered all the nucleons, 1 proton and 2 neutron, total 3 nucleons. We will get the total mass of the nucleus. And see things here, the mass of subatomic particle, mass of proton is 1.007 and mass of neutron is 1.008. Which one is higher? Mass of neutron is higher. And for the general knowledge, I would say that neutron has been invented by Chadwick. Okay. So anyway, mass of neutron is heavier, mass of neutron is higher than mass of proton, and see mass of electron, it is 0.00005 atomic unit. So mass of neutron is greater than mass of proton is greater than mass of electron. This is very important. Now as these two are heavier and these are residing inside nucleus, we would say that nucleus is carrying the entire mass of an atom, because see, this is very much heavier than mass of electron, and neutron and proton are inside nucleus. Outside we have electron and that are lightweight. Okay, thank you.